I win?
Yeah.
Did you win?
No.
You never win.
Did you win?
Did you win?
No.
What's this? Is that a new shirt?
Same? No.
Oh.
See you.
See you later. I assume you guys are gonna be tired from staying up late watching election stuff last night.
I saw somewhere that some schools are going to give students a day off, like a distress day off. Because, yeah.
Only one day? That sounds good, but they'll have to make it up, so. I guess you could have just stayed home sick for a day if you needed to.
Walking into school, who's girls walking in front of me, talking about how much they hate homeowners.
Basically, gonna give you coffee. She's nice with you.
I can't hear you.
Sure they were. She gave you
Fire
coffee.
away.
She's not there. Nice with you.
She put some white man on death row and we told evidence that she
Wanted you to
Yeah, she's giving you like 35 stories.
So that's probably not true. It's probably something that Trump said.
See, I thought that too. I was like, huh. I never would have thought he would have let a stereotypical joke like that up there. Wait. I don't even know. Because Asians are known for being A+. So calculus BC, calculus A+. I said BC is
That's good. Funny guy.
He's a funny guy. I never would have took him for the stereotypical type though.
Oh my.
Wow, it's late here. It's a first. That's a first. Yeah, well, actually, I haven't seen Blake in a while. I know, right? I think it's been like a week. What'd you get on the physics test?
Oh, I did that.
What'd you get?
What did you?
What did you get? I asked first.
I don't care.
I plead the fifth.
What?
You're violating my First
Okay.
Amendment rights.
Was yours above or below class average?
Above.
What was class average?
Like a 63?
It was?
It was like a 63 or 65.
I thought it was an 85.
Your class was even worse. Your class.
Our class had a 74.
Yeah, after you raised it.
Well, yeah.
Before the curve, your class
How did you
was like a
forget the other
51.
Yeah, I know.
I
have no idea.
I got a 93.
Also, why are you dressed up with
Melvin, I had a 93.
That's what Howdy got.
What'd you get?
I don't know. Worse.
Why you dressed up so nice?
By how much?
Grades are private, right?
Yeah, that's why I won't.
Oh, Calvin, please.
That's why I went to do, because I wanted to.
Yeah. Just 'cause I wanted to.
Calvin, what did you get?
Grades are private, right?
Oh, Calvin,
Okay.
come on. Did you show up today? I got a 93.
I did. You got a 93?
What,
Yeah.
what grade did Piper get?
Who?
Piper.
She's not in that class.
You haven't asked her?
She's
What?
not in
Oh,
that
she's
class.
just on the class.
What science class did she take?
AP Environmental Science.
Okay. I'm just trying to give you a hard time. It didn't work. How was your day?
That works on Fridays.
Wish we could open the windows. It's so nice outside right now.
Class average for your class is like 51. No, that's, I wouldn't curve it's like a 74. I think our class average after the curve was like an 85. I didn't think I did that though. Calvin won't share what he got.
You got a 64.
Like 5 and 5.
Mr. Johnson?
Calvin, you got a 63.
Is there any way to
I did
copy
not
and
get a
paste
63.
something if you
You got a 63.2.
you've done something?
Lower.
I've
Lower.
done all that.
No, I'm joking. I'm
Pasted it
joking.
there.
Okay,
I
so
think
that was
all
cheating
we
on
did
Calvin.
that. Now we're all remembering.
No, that's too bad.
No.
Actually, he and I were
It's
gonna
already
work
looking
together. We took our dividers and we went,
Well, what you could
oh,
do maybe is you could
forwards, and we were like, yes, for this one I got.
enter on all that.
And there was one time we walked out the class and he got it
There, I'm not sure.
Yeah, you did that too. I think you just like carry more students with the first.
Okay, I guess we are not starting with the minute of silence today. Several of you guys turned in that 5-question practice from last class. Was number 38. But I said if you ran out of time and you needed to do it for homework that you could. So I've got a few of those already this morning, but if that fits you, then please come and get those to me. We're going to look at just a couple. Basically, this class is going to be almost the same as last class. We're going to look at a couple more questions on assignment 37, where we're going to find area bounded by 2 polar curves. Then I'm going to ask you to do 39, which has another 4 or 5 polar questions from the first polar lesson. So that's what you just did on 38. So anything you struggled on 38 should go smoother for you on 39. And if not, that's pretty much all the practice I can give you on that section. So you really need to mark those, identify what it is, ask the questions you need to ask. And then ask you to continue on with assignment 36. So 36 was from like 3 classes ago. Last class I asked you to do at least a couple more on it. So you shouldn't have too much more to finish from that. So we're going to look at a couple questions from the next topic, practice the 4 or 5 questions from the first polar topic to get better at that, and then ask you to finish the second polar topic, assignment 36. So that you've got the basics of finding the area down. Okay, so 37. So the 10-second review of just kind of what the thought is. The area of a polar curve still fits this formula. The difference in this last section, which I showed you a few questions to last time, and I'm showing you a few more today. I'm trying to introduce it to you slowly, just because I think it's the hardest one we've had to do thus far. Basically amounts to trying to find area that's trapped between polar curves. So we had to think about, sometimes it might be part of this polar curve from this angle to this angle, and then it might be part of that polar curve from this angle to this angle. And then you take those pieces, you add them up, and then you get the area that is trapped in between them. We talked about symmetry. If you wanted the area of all of this, you could just find the area of half of it if you're sure it's symmetrical, and then double your answer. Here was a question where if you don't visualize this line or draw this line in, it's kind of hard to see where 1 and 2 parts of the area come from that's trapped. And then the last technique we looked at is if you just wanted this area in black here, you could find all of this area with what I have in red, and then subtract how much area you don't want, which I'm subtracting in black, sorry, and then that leaves behind that highlighted area. So if you wanted to know that, you could do a subtraction. Area of the whole thing, subtract how much area you don't want. Okay, and then we practice that for a single question. So let's look at just a couple more here. So find the area of the common interior of the polar curves r equals 2 and r equals 4 sine of 2 theta. So to even visualize what you're doing, you've got to be able to make a decent sketch. It's fine if it takes you a few minutes to do a decent sketch, but this one should be pretty easy to do. R equals 2 just means the radius is 2. No matter what theta is, r is 2. And then for this one, again, you can just think of it as a table, throw in some random theta values, solve for the r values, plot one point, plot another point, plot another point, and then eventually you'll feel comfortable enough to see that this looks like this. It's a flower with 4 petals. So not that you have to memorize this, but you may remember the first couple times we looked at polar, we talked about the number of petals. If this is an odd number, that's how many petals you have, and if it's an even number, you have twice that many petals. So if we're trying to find the area that's trapped in between all of these, we are trying to find all of this area. So instead of doing this 4 times, it's going to be a lot faster and probably easier, because probably less mistakes, to say, let me just find the area of this, and then I will multiply it by 4. So there's still some symmetry here. So don't just assume you're going to remember to multiply your answer by 4 in the end. Say 1/4 of the area you want, so that you remember to multiply by 4 in the end. And then you've got to kind of dig in a little bit, and you've got to try to split this up. So the better your picture is, so I'm trying to make it look a little bit better to make it a little bit easier to see, but the better your picture is, the easier it is to set up these integrations. This one is actually going to have to be in 3 pieces. So 1/2 times, and I'm just going to put parentheses so I don't have to do 1/2 in front of each one. Integrate r squared d theta from some angle to some angle, plus integrate r squared of d theta from some angle to some angle, and then this one's going to need a third one. Now, you don't know why there's a third one yet, but I'm about to show you. So if I zoom in on this, the reason that this has to be broken up into 3 sections is you can imagine this line and this line. So some of this area is trapped within this red stuff. So which one was the red? 2. So this stuff comes from the red polar from this angle to this angle. So I'm going to need to find those intersection points. So we can set the 2 equations equal to each other. If r equals 2 and also r equals this, you could set those two equal to each other. Solve for theta. Sine is a half at pi over 6 and 5 pi over 6. But this isn't theta, it's 2 theta. So then you would need to divide both sides by 2. Pi over 12 and 5 pi over 12. Pi over 12 and 5 pi over 12. So I didn't point this out on the front page, but the front page gives us two very quick hints. Thinking about symmetry makes the questions easier, and intersection points often are needed. Okay, so this is in the middle, so I'm just going to put it in the middle here. That part that I've kind of shaded red is from pi over 12 to 5 pi over 12. And that's trapped within the red polar curve. So his r is just 2. Okay, but then I've got some polar, or some area here that's trapped by the purple polar curve, here and here. In fact, those look symmetrical, so you could maybe knock out both of those if you double it. But starting at the purple polar curve from here to here, so you might want to think about what this angle is. I think it's probably 0, but don't assume that it's at 0. Plug in 0 into its r, you get 4 times the sine of 0, which is 0. So from 0 to pi over 12, I want the purple curve so that I'm getting this stuff. So from 0 to pi over 12, I want the area of the purple curve, so I'm going to use his r. And then the last piece, the third piece, is trapped within the purple polar curve starting at 5 pi over 12 until it gets to here, which I would think is pi over 2, but again, don't assume that. Plug it in. Sine of 2 times pi over 2 is the sine of pi. The sine of pi is 0, times that by 4 is 0. So pi over 2 makes sense. So this last area comes from starting at 5 pi over 12 to pi over 2 with this r. So you throw all that in the calculator, you get an answer, but don't forget to multiply that by 4, because this is just the area of one of the petals, or of the common area of one petal, but there's 4 of those. So when you do that, luckily that would, at least you could just throw that in the calculator at that point. It would come out with that as an area. So again, when I talked about the agenda today, this is not an assignment I'm going to make you practice on your own yet, but you need to start identifying what's easy about this and what's difficult about this. I think what's difficult is trying to divide up the area sometimes to see when it stops being from one polar to the other polar. Finding these intersection points sometimes takes work, and probably more than anything, being careful about the bounds. For that polar from here to here, from the same polar from here to here, and during this polar from there to there. I think that's the part that takes the most thought. But the good news is it's always the same area formula, 1/2 integrate r squared. It's just that if you need multiple pieces, then I mean, it looks complicated, but you're really just throwing that in the calculator. Okay, let's do one more where I do it for you here, and then I'd like you to try question 3, just as a trying it out before I let you put this assignment aside for the day. But is there something about question 1 I could maybe help you understand?
I would thought that whenever you would integrate from 0 to pi over 12, aren't you getting the area all the way to the x-axis right there, or you're not?
If you were using the red polar curve, then you would get all this area up to the red polar curve, but I didn't want that. I wanted the area that stuck in the purple one, so because I used this r, that's why it worked.
Okay.
If you had used this r, then yeah, you would have been finding all of that up through it. Okay, good question. Anything else I can maybe help clear up? You guys think you could have done that on your own? No? Also, the splitting it up. Honestly, I didn't mention this, but I think that's probably the hardest, seeing that this probably needs to be 3 sections. And if nothing else today, the better your picture is, the easier that is to see. If you make your polar curve so small like this, and you're trying to do something like that, the odds of you keeping up with there's 3 sections in here is just next to impossible. Okay, let's do one more as a group. Let's do question 2, and this one I think is quite a bit easier because it doesn't have 3 sections. But we could graph this and graph this. I'm not saying that a graph is 100% necessary, but it sure makes it feel a little bit easier. You don't have to memorize what these graphs look like, but try to make your graph big so that you can visualize what's happening. I actually do know what these look like because I've done enough polar. If it's just a number times cosine, I know cosine is going to be centered around the x-axis, and since it has a 2 here, it's going to have a diameter of 2. And so what would be the difference with this one? Right, this one would be along the y-axis, but he also has a diameter of 2. So I guess if you're looking for those things, sometimes you can save a little bit of time, but again, you can always just make a table, plug in some thetas, plot some points, connect the points until you're confident that's what it looks like. Okay, so in this question, we want this area. This is the common area. So it would be great if all of this was trapped within one of the curves. But notice, if you divide this up here, this area is stuck within the purple polar, and this area is stuck within the red polar. So I'm going to need to do this in 2 parts. So should I put like 1/4 A or 1/2 A? Do I need to do that this time?
No,
Why not?
we don't know if they're proportional.
Sorry?
Do we know if they're equal to each other?
Oh, that's true. If these were equal to each other, I guess you could just do half. I was just saying that you don't have symmetry where this area is also down here that we need to find. So this is the entire area, unlike the last question when I just found 1/4 of it and I knew I had 3 more of them. So our answer will come from the area of a polar curve formula. But it's going to be split into 2, it's got to be split into 2 pieces, as shown by this line. Bless you. So sometimes it's trapped in this, the outside is the purple one, so sometimes we're going to use 2 sine theta as r, and then sometimes it's trapped within this red polar, so sometimes our r is going to be 2 cosine theta. Okay, the last thing to figure out is the bounds. So if I'm looking at the purple, I think it's starting here and ending here. At the origin is usually 0, but polar can be tricky because depending on what r is, it could be negative and it could be flipping around or something. So if I plug that into his polar curve, I see that r is 0. So when you go in the 0 radians direction, r is 0. So I'm good with that. So I know this one's starting at 0. And I want to stop using that polar curve once I get to this point, which is the intersection point. How am I supposed to figure out this intersection? Good. So if 2 cosine theta equals r and 2 sine theta equals r equals r. So those have to be the same. You could divide both of those by 2, and that's all you can do algebraically. The rest of this, you've got to know your unit circle. When is sine and cosine the same values? Right, and doesn't that look like we're kind of going at pi over 4? Probably perfectly if my graph wasn't hand sketched. So this is at pi over 4. So I want to stop including the purple polar at pi over 4, and I want to start including the red polar at pi over 4. Okay, 5-second guess. What do you think this angle is that I want to end with the red polar? Okay, very good guess. I was thinking you might say 0, because a lot of the time the origin has 0. But this is turning, 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 and it's trying to go up the whole time, so it's trying to get this area up to pi over 2. You are correct if you thought it was pi over 2. But again, you don't have to guess. You can plug it in and check. I'm looking at this one. 2 times the cosine of pi over 2 would be 0. And in the pi over 2 direction, it's not going up at all, so that makes sense. So I can confirm it with just a second of work. All of that could go in the calculator if need be, but the one other question I'm asking you to do on this today is number 3, and you can see it's multiple choice. So sometimes they're going to set it up for you, and you just kind of have to figure out which one of those makes sense. So again, I'm not expecting you to feel like you're a master at this yet. I'm trying to show you that the area of polar is important, because that's the assignment you're going to finish up at the end of class today. And you can see what we're building up to. It's not that this is harder calculus, but it takes more thought into seeing how these pieces get added together. Yeah.
Why does, like, when you go from, like, say for the purple one, why is it only going like that little small sliver? Wouldn't it go to like the center of the circle? Or would it get all the area?
So you think this should go further?
No, I was saying like,
You're saying would it get all the area to the x-axis? Underneath the circle?
yeah, like to like the middle of the circle.
No, because I think what you're thinking of is like area under a curve with integration, but these are not in terms of x and y. Since these are polar, it's calculated in to not go all the way down to the x-axis, if that's what you're asking.
So it's just because it's polar, different form.
Yes. Because as this angle changes, because you're doing all the angles from 0 to pi over 4, so as this angle changes, what you're really doing is you're finding this radius length, 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 this radius length. And when you do that an infinite number of times, which is what integration does, you end up with the area. So, okay, I only want you to try one more of these for me today, and we can go over it next time, but I'd like you to try question 3, and in 3 minutes I'll tell you which one of those answers is correct. So, not anything you need to throw. You could say this would be like a no calculator question. You wouldn't need a calculator for number 3, because there's just asking you to try to figure out which one of those setups looks correct.
Mr. Johnson, I have one more question.
Oh, sorry. I thought.
So, pi over 2 times pi over 2 is 9, or sine of pi over 2.
Is 1
times 2 is
2.
2. That doesn't equal 2 cosine of 2. Whenever we're trying to determine, after we've already integrated from here, now we're coming back down to here, trying to find our second bound. Don't you set them equal to each other, or did you do something different?
Well, sure. They're not at the same place at pi over 2, because that angle's not pi over 2. Pi over 2 is the one that's straight up.
Right. So it doesn't, oh, so there's not an intersection there. So we're not looking for an intersection.
No, we did.
Right there we did.
But to find the intersection, we're not plugging in the angle, we're trying to find the angle. So I said that this is R and that's R. I said those two equal to each other. I didn't plug in a theta though. Divide both sides by 2. And then when sine is the same as cosine is when they're in the same spot.
And that's intersection. then how did you guarantee after we guessed that this was pi/2? Not at the beginning, but at the,
Oh, how did I know?
The second time, yeah.
Okay, so pi/2, I don't care about this one at pi/2. I only care about this one from 0 to pi/4. The second one I care about from pi/4 to here.
Right.
And so you guessed pi/2. I took pi/2 and plugged it into that one. I'm sorry, this one. The one I was trying to get area from. I'm sorry, I lied. I'm plugging it into this one. Cosine. And so what is 2 times cosine of pi/2?
0.
So for this polar curve, if you try to go pi/2 direction, it has a radius of 0, which lands right there. And that's where I need to start.
Thank you.
I'll be honest, I have not done this question 3 yet, so. Okay, there was 3 minutes, but I'm gonna give you one more. I can see people are still thinking. I just want you to make a good, strong, educated guess before you actually practice some of these another day. Okay, so just for time purposes, we'll go over question 3 to start off class on Friday. This is an A week. They haven't had an A week in a little bit. Actually, that's a lie. It's B weeks we don't have a lot of. Anybody confident in their answer? Want to share what you got? What you get?
C.
Anybody else get C? They are correct. It is C. So if you didn't get C, leave your answer there, but maybe show that C was the correct answer. But we'll go over it on Friday to start class so that you can see what maybe you didn't think of or what you might have done incorrectly. Okay, if you would please, to finish up class, so 39 is just like 38. It's whatever, 4 or 5 extra practice questions from our first polar lesson. This is the stuff that you got extra practice on last class. So if there was something you struggled with last class and you had to put some extra effort into getting it figured out, this one should go that much smoother. But again, I'm trying to give you as much background practice as possible before you are responsible for being able to do this last section, this last polar section. So do those 4 or 5, please. You've got the answers on the bottom of the page. There's only 2 of them to tell you to use a calculator. So I think it's the last question, and to help identify your correct answers, I think on question 3. And 5 questions. And then finally, from like 2 or 3 classes ago, when we started doing area from polar curves, I don't know, you did quite a bit of it, and then last class I asked you to do at least another 1 or 2 from that, so you should be about finished with that, and I need everyone to finish that so that we're all on the same page. So from now, you've got just a touch over 60 minutes, so I think that should be pretty easily achievable without any homework. But please let me know if you found something I can help with. Now, I'm passing your homework back to you. Please don't use your homework on this assignment 39. You really need to be seeing what you can do without hints and without your neighbors and without the notes. This is the third different class I've had you practice this topic, so if something's still going off. We need to make it a priority.
And then cotangent is number 6. Yeah, more than that. There's gotta be. There's gotta be this one. There's gotta be another.
But they did not say because it was
One time or 2 times.
So the one. Oh, accidents ago. So it'd have to be.
So there could be -2, just actually, that's exactly what we thought. -2.
So it doesn't? Doesn't work. Because, so 3 prime 2 equals C plus 1. Cosine 3 cosine 3 prime 2 is 0.
Yeah.
And then cosine squared of 3 prime 2 is negative 1 squared plus root of equals 2. That's it.
Again, this assignment 38 is the same type of practice as you got on, or I'm sorry, 39 is the same type of practice you got on 38, so it should be going a little bit smoother than last time.
I changed that same square root to 1 sine square theta. You can't. Sine squared, let's go sine squared now. Because otherwise I need pi. Yeah, I'm stuck. I didn't make it that.
Oh, 11, 5, or 6 are the same side. That's We'll have to ask them because of these.
What do they score usually?
Also, is Mr. Townsend?
Yes.
Number 5 out of 36.
Thought of solving this.
Number 5
I
on
said that take
Number
number
5
5
are
give me the Arvanici.
Yeah.
Right. And then since theta was in there, I had to take with respect to theta. That's why I moved it with respect to theta, so this multiplied against it.
Right on the graph from 0 to 2 pi.
Yeah.
So what I did is just like going 2 pi minus the graph multiple times, if you on the graph
That was the correct answer.
Right.
So then the graph maybe fractal y or whatever.
I was not here for that.
Now it's going to graph more.
I think the
It just took some more turns to get the whole thing.
Apparently Walmart's working.
I can't wait for advisory today.
Why not?
What is that?
Well, you're gonna be in here.
Yeah.
So is your sister.
Oh, really?
So
What the fuck's that?
they'll stop talking about each other behind each other's back and have to get it settled.
See the beef.
Are you gonna fix the clock?
Did you tell me to fix the clock the other day?
No, I don't think so.
Honestly,
We were
really
joking
well.
though, that.
Somebody told me to fix it.
Oh, yeah.
This morning I slept through my alarm, so I was late to practice.
Oh, really?
What happened there?
Well, I stayed up watching that lecture. What pages?
How late did it go?
Wait, no, this is. I stayed up till like 11. I was.
You didn't know there was also like two others.
Ultron.
But did you know that there was also one?
Oh yeah, you didn't actually find the number.
New one, but we were also still like, maybe there's like a 2% chance. That would be so back up.
Where was he at? Yeah, check. Yeah, I think it's 16.
Last time I remember, she was 65.
Oh.
64. I was like, there's no word.
Thank you.
Because we're still the same size.
These are all like
Yeah. What does for the swing state? You got it.
It makes the radius more bigger. So where if this wasn't here, anytime cosine was 0, it's gonna be at the origin. But if you add 4, it's gonna just spread everything out. Make everything easier. You can also just graph those. Graph what you're going for and graph what you're looking for. So either calculator, then you can visualize.
These are connected.
Well, I mean, for something like that, to help you understand it, don't do it to get the answer unless it says to. Y'all do recycling?
Investors?
Yeah.
Just recyclable?
Probably not.
I would. Why say no?
I feel like one of the
Isn't it
girls would
cardboard?
say no. That's why.
I feel like they would be. They're compostable. Yeah, if anything, you can bring those and put them in the.
You know what?
Bins
Yeah, go
downstairs.
for it. There's
Yeah.
no harm.
No.
Okay. I'll put them in the recycle and
Yeah.
see what they do.
And then whenever they yell at Mr. Johnson, he's gonna go.
They don't yell at Mr. Johnson, they always yell at me.
Bring the gloves and next to test one, see if that's what It's
You know
fine,
what?
I'm
I'll
used
take
to it.
responsibility for it.
No, it's fine.
Yeah.
I
Just
get
send
the
them our
blame
way.
whether it's my fault or not.
Yeah.
Send them our way if they. Send them.
The picture on the thing is a picture of a sea.
I wonder why there's a chair.
Yeah, why is there a
I
chair?
thought it was a box for a chair.
Me too.
I was like, what?
Because it's cozy. Look how nice and relaxed you're gonna be if you buy this heater.
Elon is like, I thought it was just.
I would like the couch. I would figure they put the heater in the middle of
I think
it.
it's
Not the chair.
The marketing part isn't quite there.
One, second was like 11.7%. Yeah. Because it's so boring, so it's like. This is insane. I'm surprised the market's really well. I know. I kind of thought it.
thought no matter who won.
That'd be like 10. You thought so? Everyone, but this is still gonna be like a word. Yeah. I agree. Yeah.
My guacamole is gonna be so expensive.
You think?
Yeah, he's putting a 20% tariff on all
What?
imported goods.
Guacamole?
Guacamole.
Yep.
What?
That's only if we buy it from Mexico.
Make our own guac.
Well, like,
We don't know how to grow avocados in America, Thompson.
Apparently not.
look. What about you know about that? That's like avocados from Mexico.
I didn't even know what it is.
Yeah, the cartel owns that company. You know, they actually do that too.
Ben, are you finished?
No? Who told you that?
Who told me that?
Yeah.
I remember listening to there's this guy who was talking about most of the avocados in Mexico are all owned by the cartels. And I wanted to do it. It is literally owned by the cartels.
Everything in Mexico.
Okay, you still got about 35 minutes, but I would like assignment 39 as you finish. There's no reason you shouldn't finish those 5 questions in class, even if you need help with all 5 of them.
Holy smell. What question was
This one.
I was like, wait.
Oh, they gave me the answer, Dexter.
You got the right answer. Mr. Townsend, do you, when you're doing this question and this question, is dr over dt the same as dy over dx? You know, where you would use your polar, right, y equals sine of theta, x equals cosine of theta, and you multiply that by r. Are you able to attain the same value by just taking the derivative of r here, or derivative of r here, to find the instantaneous rate of change, as you would by finding y theta or x theta and then doing y equals x?
Yes.
So you don't have to do this whole, this would get you the right answer, but this is a heck of a lot more work. Where
I'm not even sure that will work, to be honest. Because if you find dy dx, you're finding the rate that y is changing with respect to x. But you want to know how r is changing with respect to theta. So there's just different stuff.
Well,
I would just
have to
take
do is you have to do
derivative of
r
this whole thing with respect to t, just like you did. That's your r prime and a theta prime. Plug in your information and you're done. And same with this. When it says instantaneous rate of change of r, it just means the derivative of r. So you don't need dy dx. You just need r prime. And then plug them in.
what would it look like if it were asking for dy over dx, where you use your knowledge that y equals sine of, or r times sine of theta, x equals r times theta?
Okay, so you start with those two. You plug in what r is for both of those two. You take the derivative of y to get y prime, and then take the derivative of x to get x prime, and then y prime over x prime will give you dy dx.
And what does the question look like if it's asking for that? How do I know it's asking for that versus just?
If it wanted to know the flow of the tangent line there,
Slope of the tangent line is that.
yeah, so like
Like number 1.
that's what it says inside the
On the 38.
because if you have something that's polar, if I want to know the slope at this instant, that's that.
Okay.
But r prime is how fast this is changing.
Okay.
So there's two different things. But if you wanted to know the slope at a certain theta,
Yeah.
the rate of change of r, but the slope of the tangent line, you would want dy dx.
And the rate of change of the tangent line would be d2y over d2x? The second derivative of dy dx?
Yes.
So
So you do the derivative of dy over dx over dy over d beta over dx d beta, and then you divide that over dx d beta.
What do you divide with dx d data afterwards?
Because it's a parametric equation.
I will plug that in. See if my secretary works.
Yeah. You guys are?
I'm just gonna cheat last one.
We're done. Interesting. Yeah. I wonder if it's like. I wonder if it's like.
I think I need to buy like, you remember those pads you would unfold in like grade school and you'd have nap time?
Oh, I would love that.
And then start having RTI nap time sessions.
That would be fun.
I think
You could
that'd
do
be,
that, or you could do yoga mats as well. That's a good one.
just get a collection of pillows and mats and turn the lights off and play some sleep sounds. I have a feeling I don't think I would be allowed to do that very long.
I think my recovery would be so much excelled that school would just be a breeze. I would be so locked in during the school day. We should make that
Well, are you done with this?
I'm on the last question, double checking my answer right now.
Okay. Well, I'm just saying, you could,
Almost.
you know, I don't care if you sleep once you're done with what you're.
That's true.
Mr. Townsend? We're taking derivative, so we have the derivative of x and derivative of y with respect to data.
Yeah.
Do you have to do quotient rule, put those on top of each other? Because isn't it,
Wait, well,
Just because the urban hubs would be predicates.
perfect. But, yes, this is exactly right. I was afraid you would forget this. That's kind of hard to understand why we got this. But since this is a calculator question, I personally wouldn't feel in my hand and I would try to get all that type in the calculator.
Right.
So,
if we had to do it by hand though, do you have to,
so
you would need to go here?
you'd have to put y prime over x prime, you get this. And then you'd have to do the derivative of that, which would be quotient rule. And within that, you're gonna have some product rule, which is why it gets real messy.
Gotcha.
It's possible, but
Okay.
I would avoid it if you have a calculator.
They're gonna care about it. Yeah, they should. It affects their work times.
I was like, do you have to be in polar form to do that?
Yeah. I don't know if it's smart enough to figure it out if you had an answer.
Probably do the same.
I think it would probably work out because you would just be replacing betas with x's, but you would also be plugging in 5 for x and 5 for theta, so I think it would be fine. I think it would balance out.
Okay.
Cause like, The way I did it.
Brayden, you've only got a couple months left. So you can get out of high school.
But she doesn't have, right? She would.
Stay in band.
No, I mean, March of the season. Yes, Monday was supposed to be our last.
38.
Arranged to go and push it out another week. So we
Good thing you won the girls' race because Brendan was making a move the other day.
Oh! Making a move?
Mr. Townsend loves to give me a hard time, doesn't he? Love you too, Mr. Townsend.
I've seen you talking to her quite a bit in the hallway 2 times now. And that's not even trying to snoop.
Yeah. Yeah, Ben, you're right. His jokes are getting balls.
Gosh, Ben, don't say that about people.
Come on, man.
Ben, you're gonna get beat up.
So you said there's a lot more people who you feel like are still being almost supporters. What were you saying?
I agree with you. We should get some new jokes.
Which is kind of
You said what?
So theoretically, it says right now, why did you just find the area of the whole thing and then divide it by 3?
it wasn't.
Because just like trash.
I still think that they're.
God.
You're wearing socks with holes in the Crocs.
Mr. Townsend, theoretically, I'm supposed to find the area of 1 petal.
I don't throw away
I just
socks.
find the area of the whole thing and then divide it by how many petals there are.
If you think that's easiest, sure. Wouldn't it be easier to just find 1 petal than it would be to find all 4 and divide it by 4 though?
Well, it just says right, but do not
But no,
solve
socks, I have
an
20
expression
socks.
of the area enclosed by
Socks are
1
so
of
cheap.
3 petals. So I just,
I'm at Sam's all the time. So you try to do something. I just walk in and do live. You guys show I picked up some.
Divided by and what 2 is going to do.
You're like,
Pretty long range.
those 2 of 6.
Good job.
It's like,
I never heard of them before.
what question you on?
I'm done.
Wait, oh, no, 36. Oh, are you on 36? Oh, haven't started yet, okay. Well, me neither. I'll take the easy.
here's another one.
Right. What question you on?
Mr. Townsend?
Yes,
I
sir.
just don't know.
Oh, you got a math question, okay.
Got a math question.
The other ones are all
I never know what
the small ones, so I don't know what I
On question 3,
That's the whole thing.
we got it down to where we set that equal to 0.
Okay.
We're trying to solve for the various theta values.
Okay.
How do we solve that without a calculator? Is it just plugging in values and seeing which ones work?
Same thing for this one. It's
Have you checked to make sure that this part's right first?
Not necessarily.
Okay.
How do you find these?
Well, what you could do is, so you've got a sine here, you've got a sine squared here, and this cosine squared, you could change in the sine stuff.
What is that?
You could call this 1 minus sine squared. And then, if you distribute that negative, it's going to create a -1 and a...
Positive sine squared?
Right. So then you can say you have 2 sine squared minus sine minus 1. So it would be like assume that when you graph this, then you have, what do we say, 2 sine squared?
Minus sine, minus 1.
Yeah. And then factor, you can just pretend like these are x's. 2 sine times sine squared.
You could do that.
Plus 1, minus 1, plus negative 1, and foiling for that. And then you can figure out where this is true and where this is true.
It's like grapefruit.
And now it looks like made of circles.
Also looks like.
I was thinking about that. Obviously seeing the sine squared and cosine squared, I wanted to find a sine squared plus cosine squared to set it equal to 1.
Mm-hmm.
And then I was also debating if there was something I could do with the numerator to cancel something, but I don't know if there was. But
The problem is, yeah, so you're on the right track because usually doing a substitution for sine squared plus cosine squared is good. But if you're looking at this, like these either can both be positive. This one could be positive if this one was negative, but only if you have a positive 1 to pair up with it. You need both of those to change it to this. And so sometimes the signs aren't quite right where you can use that. I think that's the case there.
Okay.
So it was close, but yeah.
thank you.
Yes, you could. And then you get it back like this. It'll make you feel better. I used to eat it. There's old ones that were all expired.
These are so nice when it says right, but do not solve.
Not trying to compare it, but.
No, I mean, kind of like this is getting so. I just switched wash. They're really old. To the point where it tastes.
You ever had expired popcorn?
Oh, yeah.
Yeah. That the oil almost collects throughout your mouth and it's.
That's right.
It's like a cookie.
You ever had expired milk?
Yes. Not a whole lot of it because I barely stopped.
It would expire disease.
That's a triangle.
I had a whole bowl of cereal with expired milk once.
Oh, really?
I knew it tasted kind of funny.
I didn't have, it wasn't terribly expired, but yeah, I did the same thing, and I was thinking, what is wrong with this milk? But if you have good, or if you have a cereal in there that has a lot of sugar, then it doesn't taste terrible, so you can get away with it.
That's good. I remember I made breakfast burritos. This was only about 3 weeks ago. And as I put the cheese on it, so I made really nice eggs. I made some sausage, put on it. I made breakfast burritos for everyone. And I put cheese on top of it. And as I did that, I realized after I started eating it, that it tasted a little bit like I was eating like a aged brie. It was like a sticky cheese. But this was just the Sam's Club shredded normal cheese. And so I look at it, and it's got these little fuzzy things inside the cheese leaves. I sniff it, and it smells like a stinky cheese, an aged cheese.
Was it old or did you
It
just?
was expired and old and moldy. Or something.
We bought a block of cheese like 2 weeks ago, and before we even opened it, we realized it was moldy and took it back.
Really?
It's nasty, isn't it?
Yeah. Well, I mean, cheese is already kind of like that.
That's true.
You might have made a fancier, more expensive cheese, but I did.
I didn't get sick, so it was fun. But my dad still wanted to throw everything out because he did not like it.
Yeah.
I was fine. I ate my half.
Okay, so to do this version of the is either on the stupid now/on where it's going like why like
It's alpha.
Most of the time I do windows, yeah, I normally do the second before. Derivative.
Is that this one?
Alpha
Is
window.
that this one?
Yes, but not like that. Nope.
Alpha window, then you go right, you get fraction. Thank you.
Yeah, it does.
Or you go left, not right.
So 4 just always looks like other
Yeah.
numbers.
Other right.
Need to think that.
However, seven stocks.
And this is how I write one. If I mess up the one, I do it quickly. Then the line goes through, it becomes a set.
So I've got my writing, just whenever I myself. Never mistake for anything else, because my ones are blind.
Stocks now, just straight, white or black, that lines on. Really?
Used to be I'd rather
This
look like
quarter,
that.
I thought we rolled out.
Yeah, they're bright colors.
I used to have more like that. So that they were more distinguishable.
I think
Nasty.
Ones like that,
Nasty.
so they were more distinguishable.
Wide ass.
Nasty.
But-
What, how's it hurting? How's it?
This is my
You
one.
think it's hurting people's perceptions of me?
No, I think it
This is
just
my
makes you a nasty person.
Which is why you can't do
Really?
4s like this.
It's like whenever you walk in a punk out fingernail.
So you can do
Just
exception.
a,
Why?
it's like a lack of hygiene and then a lack of self-control. I think that's a perception you take away from it.
I think it's
Very close to.
I think I have a lot of respect.
You're one of those people who
start celebrating Christmas
before Thanksgiving?
That
No.
I'm not.
When do you start playing
Yeah.
Christmas music?
hygienic, right?
What about it?
I don't respect
When do you start playing Christmas music?
So that
I respect
What's wrong with that?
Exactly.
For example, don't care a lot
November,
about what
like,
they're wearing.
It's a math thing, not a Christmas thing.
You know, they just have banded hair. And just, yeah, they just have banded hair, and they have the confidence to
Yeah,
say.
no,
You don't see the math symbol?
Oh,
At least
I saw it, yeah. I know.
Also
I
pronounced
don't think I look
sheets.
with holes in your socks.
You think I look?
It's up-
I think the holes in the socks adds to the eyes of it. You can walk outside on the street and just start messing with it. If you mess with it.
Doctor, and it wore these.
Thanksgiving.
Wore these clothes. You think that someone would go
Rub some dirt in it.
You did.
So there you have some various constituents, various constraints or other things that I have to do to qualify to look homeless. So I don't look homeless right now.
Maybe if you make your shirt up a little bit.
So I guess it's the same thing for you. If you rip your shirt up a little bit, put a little dirt on it, you go outside and you look homeless.
I will not look homeless. I'll look too nice.
You would.
Just couldn't help it.
Yeah, I guess.
You see, look, they say, your socks don't pulse them. You're not homeless.
Theoretically,
Gravity is taken into account.
I love homeless people. I don't know socks.
There's other sock drags.
It's not that much.
Right.
It's the smallest.
Yeah,
That's what I'm
it's
saying.
not that much, it's not gonna change the answer.
How do you like
On day 0,
Yes, he'd be
so that's like a party.
on day
You're
1,
homeless.
he'd be at
Which is a different thing.
There is.
He's not homeless.
Day 2 is 2 feet, day 3 is 3 feet. On day,
It's better than other people.
you're not gonna count. It's on day 0.
I haven't seen it.
So on day 8 p.m. On day 9,
It's fine. I get a lot of presents at once. I don't know if it's a good thing.
It's not Fred. It's not Fred.
I cannot pronounce that 4 R's.
Yeah. That's what it is. I feel like I never know what I want. And then people are like, what do you want for your birthday?
Day. Day. Pretend you're gonna say B, just make it really plain.
I'm a little bit confused about number 5. Because didn't we find the area of the graph of r squared and not r?
It's at 1 loop.
1.2.
But it's r squared equals this.
Okay.
And it's like,
Me personally?
we didn't calculate the values of r like with a square root there. We just calculated
Oh, I see what you're
r
saying.
squared.
You're pulling back too much.
I said me personally, I just think it's falling the way. I'm gonna throw it is.
Yeah.
This is just one integration, we don't have to do a second
Are
one.
we just integrating from like 0 to 2
So smart.
Let us dive off.
Okay. Could you just do this? Yeah. I think I'm not really sure, but I think it's a weird thing to do.
What's that from? What assignment is that?
I'm gonna
36.
36? Okay, let me look at it here in a second.
Just be.
Because it's not jumping out at me. Let me see what I did on my work in a minute.
It's weird.
So find it.
Because it's civilization doing this.
You got it. Are you weird as well? Are you done?
No, because I'm thinking.
You don't have to. It would just make
They'll just know what you're thinking.
Food barn.
Nick.
Boot barn. Boot barn.
Food barn. We should do that today at lunch. Did you see him text on
No, I don't take attention to that.
You know, everyone's grouping?
Yeah, I don't take
I think X ran into him, and X took a picture of him, it's his car is gone. Food barn's car was, it like ran out of coolant, and was fucking at something and explode on their head. And he texted, he was like, food barn, all caps. You need to take, white hard-boiled eggs.
That's probably
So you know
Food barn?
you know the part
Yeah,
where
that's
there's
hard.
like
He was my
a
roommate.
explode
Exploded inside the
that
microwave.
dips up in your house?
Who's
I had
your
one roommate that didn't like me.
Who?
My first roommate, I don't know what.
Wait, you had two?
Touch it for a half second.
Yeah.
Why?
I switched to Rotzi kid. Rotzi kid's a good kid.
You switched?
Yeah.
Why?
Because this kid was,
Kind of
he
that.
wanted to switch. He was like, hey, can we please switch? Can we please switch?
What's his name?
I don't know.
Never mind, I think
Ow.
It was this little,
Oh, well,
little rock.
I found my work and I hadn't finished that question yet, so that's probably why I didn't know right off the top of my head. What did you do?
I think it's just because it's set equal to 0 in this, so it doesn't matter.
Oh, so who'd you go with? Who did you end up?
I ended up with the JROTC kid.
I still need to do it for myself
So
though.
you're
Yeah.
And you're right, it's pretty hard to see back
I
here.
don't remember what his name was.
Yeah, it's
Especially if I was a
dark.
star.
It's very blanket. Or blanket.
Yeah, it's real hard to see. Like a crew cut.
Yeah, really short blanket or no?
No, crew cut.
What time is it?
Brown
What
hair.
time do we-
Oh.
You might remember him because he was in JROTC. You walked like that.
I don't remember it.
Well, remember that?
Bro, you literally have a space heater.
Yeah, that was what my roommate was. He was 2 days.
Oh.
Here.
Before that, I was with a quiet kid.
Gotcha.
Hey, Brendan.
Huh?
You free this afternoon? To the gym?
Can't see that.
This afternoon.
How are you doing next?
We could
So
go
we'll definitely
easy.
go tomorrow morning.
Yeah.
This afternoon, I'm going to have.
Struggling.
I'm not free this afternoon.
We keep talking about stuff.
What you got going
I keep
on?
overbooking myself. I'm trying to make it happen. I'll tell people I can make this, I can do this, I can do this. And then I go somewhere and I'm, eating dinner with someone and I'm like, okay, I gotta leave now. Dinner's over. I'm running out the door trying to go somewhere else.
I don't know.
I show up 5 minutes late for that.
I skipped this one, went straight
I'm
into
good, I
it.
still have to get on time.
Try to figure
Which one do you
out
start
what
with?
I just figured that you would always
Yeah.
get
I
I can hit
full
sack
cycle.
of arms because I didn't really do it all that much.
Yeah, I hit it pretty good, I'd say.
You should.
It's super bad.
I'm a force. Like this one.
Okay, so I have very study, and I think do a
I mean, I can't do it.
did it.
Like I just
Like if
don't
you're
draft
But it's not fun, that's just so much like.
So if you're musically, if you're gonna like take a musically
This is
aptitude, I'm pretty decent at it.
I only can play piano
because
I can
Like, no, if you can sing. If you can sing and recognize pitch,
So-
then you're better at, then you're better at
notoriously bad at recommending.
pronouncing things in other languages because,
And one little fourth over.
pitch and tone,
Not because I recognize what you do. I was like, look at mine so much that I kept up.
Being able to recognize pitch and tone in music means that is like that's sort of the same area as like the recognizing tone and pronunciation. And being able to mimic those pronunciations with tone are easy.
Yeah.
Means that you're better at
It's a pretty daily thing for me. Trying to get it all
It
back.
also means that every time I listen to you and my mother Spanish or Japanese, I die.
We're wondering what your approach would be on problems like these. It's not an intersection.
My mother doesn't know.
It's just finding the area within those curves.
Well, first I would start with some sort of a picture.
Always need a picture.
Yeah, what I have to do actually.
So I plug in some data values, solve for R's, plot the points, so I can see what I was looking at.
But how do you know if it ends up being a graph or a graph like this, like this, where it has a loop?
You're not doing enough points.
And this says inside the graph. Does that mean the whole graph? of
Right,
this?
that's what I'm wondering. Yeah.
Well, this one says inside the smaller.
That's what that one
loop,
means.
So that implies that there is
This
a
one.
smaller.
And then this one inside the graph.
Right, and that's also Limicon. It's saying it's Limicon. So where are you finding?
Well, a limicon can also be no loop. It can just be like this little. It can be the whole thing as well. So I'm not sure what that has to do with this one though.
Because it's also Limicon.
Okay.
So if you're,
So it's saying inside the graph, so the whole thing.
which means if you,
I don't think that one has an inner loop.
It's a complete circle, or not circle, but
It's not a
it's
circle, but yeah.
it's not a.
Not quite a
It's like
cardioid.
an oval.
Yeah.
gotcha.
So
So
area equals 1/2.
1/2 integrate
R
squared.
squared. Yeah, easy.
Okay.
How do we
And then-
find the balance of those?
Okay. Well, pick a starting point.
Squared. 0. D theta.
Okay. So when
Say
theta
0.
is 0, R is what?
6.
Okay. So when is the next time that R is 6?
Oh. R is gonna be 6. 2 pi.
Okay. How'd you get that?
Because cosine is 1 again.
Because that pi would be negative too.
Okay. So try that in your graph. Jump to that point.
Try 2 pi.
Well. Okay. Yeah. 2 pi is definitely going to be the same as 0 because those are coterminal.
Okay.
But here, so here's what's happening.
Mhm.
Obviously, you don't always have the calculator, but if you
Yeah.
trace and you start at 0,
Uh,
you could hit trace and
That's the noise of frame to face that we do. That's literally just do that stupid shit.
there we go. Okay, so as theta increases, you see how it's plotting these points. It's
Yeah.
calculating R, plotting that point. Keeps going, and then you can kind of see theta. You see how it's approaching to get back to where you started. You see how it's going to get to be about 6.28,
yeah.
which is 2 pi. So
2
you
pi.
could see that you had to go all the way around to get 2 pi.
Okay.
Now without a calculator, when you're making that graph and you're plotting these points,
Yeah.
you're going to have to keep going and keep going and keep going and keep going until you see where it connects. So that's how
To
you
make sure it's not going around twice or something, right?
or only half or right.
Okay.
Yeah.
Wait, but when you plug in pi, you get 2. Oh wait, yeah.
When you plug in pi, you get. Yeah.
Of course, you could do symmetry too. It looks like.
Yeah.
It looks like you could do 0 to pi and then double your answer.
True.
So, if you think that's easier.
Mm-hmm.
Got you. Okay. Thank you.
Oh, I'm sorry, I did not give you better warning here, but we've got